Okay, we're going to talk about radicals and properties of radicals, and there's quite a bit to this. So evaluate and simplify square roots, the first one. So consider x squared equals 25. So what values make this true? Now consider what's the square root of 25, and that's going to be, obviously, the square root of 25 is 5. I don't know why it keeps going back to that color. Okay, so to evaluate the square root of 25, it's important to consider the principal square root. I mean, if we think about this first one here, there's two values at work, like if x equals 5 or negative 5. They both would square to make 25. But when we're looking at simply the square root of 25, we get the answer 5 because that's a principal square root. So that property states principal square root of a is the non-negative number that when multiplied by itself equals a. So the key to it is non-negative. The principal square root is not a negative number. It is written as a radical expression with a symbol called a radical over the term called a radicand. So the a is the radicand, and this is the radical symbol. Radical symbol is this check mark thing. Okay. So evaluate the expression. Square root of 64 is 8. This is an interesting one. The square root of the square root of 81. So that's the square root of 81 is 9. Square root of 9 is 3. What's the square root of 9 plus 16? That's going to be 9 plus 16 is 25. That square root is 5. And the square root of 25 plus the square root of 36 is going to be 5 plus 6. And that's going to be 11. So use the product rule to simplify square roots. So this is one way, a tool that we have to simplify, to break it down into an easier way to see it, and leave it in exact form, not some decimal approximation we get from the calculator. So the product rule for simplifying square roots, if a and b are non-negative, the square root of the product ab is equal to the product of the square roots of a and b. So the square root of ab is square root of a times square root of b. So if you can find a perfect square factor in there, pull it out and evaluate that. So given a square root radical expression, use the product rule to simplify it. These are the steps. Factor any perfect squares from the radicand, write the radical expression as a product of radical expressions, and then simplify. So on to our next example. Square root of 500, I would write that as the square root of 5 times 100. So the square root of 5 times the square root of 100, and 100 is a perfect square, so it's going to be 10 times the square root of 5. Perfect square means something times itself. This next one, 50, that's 2 times 25, where 25 is a perfect square. We have x squared. We have y squared times y, and then we have z. So the squared things can come out. So the square root of 25, let me do this in a few more steps. We can look at the square root of 25, the square root of x squared, the square root of y squared, and times what's left is 2yz. So we get 5xy times the square root of 2yz. Now to be technical, some people may write this answer as 5 times the absolute value of x times the absolute value of y times the square root of 2yz. But I don't think our book is being that particular. Okay, given the product of multiple radical expressions, use the product rule to combine them into one radical expression. So express the product of multiple radical expressions as a single radical expression, then simplify. So for example 3, we're going to have, we can combine these into the square root of 50x. That was pretty sloppy. That's going to be 50x times 2x. So 50 times 2 is 100. X times x is x squared. So the square root of 100 times the square root of x squared is 10x. And the quotient rule for simplifying square roots, if you have the square root of a over b, it's the square root of a over the square root of b, where b can't be 0. So given a radical expression, use the quotient rule to simplify it. Write the radical expression as the quotient of two radical expressions. Simplify the numerator and denominator. So we can write this as the square root of 2x squared over the square root of 9y to the 4th. Now the 2 is not a perfect square, so we can't bring it out, but square root of x squared is x. So x times the square root of 2 over 3y squared. And then this next one is to simplify the radical expression. So we could bring this under one radical. So we have 9a to the 5th b to the 14th over 3a to the 4th b to the 5th. So the 9 and the 3 reduce, leaves a 3. And then we can subtract a to the 5th, a to the 4th, subtract the powers. And let me go back to blue here. So we'd have the square root of 3a. And then we have b to the 14th, b to the 5th. That's going to be 14 minus 5 is 9. So we have, let's go back here, b to the 9th. So we could break that up to be the square root of b to the 8th times, clean this up, the square root of 3ab. So b times b to the 8th is b to the 9th. I brought this out so I could do the square root of b to the 8th is b to the 4th times the square root of 3ab. So operations on square roots. Given a radical expression requiring addition or subtraction of square roots, solve. Simplify each radical expression, add or subtract expressions with equal radicands. So right now these don't look like equal radicands, but 48 is 3 times 16. So we can write this as 5 times the square root of 16 times the square root of 3 plus 4 times the square root of 3. So that's 5 times the square root of 16 is 4 times the square root of 3 plus 4 times the square root of 3. So that's going to be 20 root 3 plus 4 root 3. Get down space here. So 24 times the square root of 3. And for the next one, 18 could be written as 9 times 2, and 98 could be written as 49 times 2. And one strategy, 9 times 2 is easy to see. This one, 98, may not. But given that I was going to be stuck with the 2 under there, think about what this would be, leaving a 2 under there. So this is 15 times the square root of 9 times the square root of 2x minus 12 times the square root of 49 times the square root of 2x. So we have 15 times 3 times the square root of 2x minus 12 times 7 times the square root of 2x. 15 times 3 is 45 times the square root of 2x minus 12 times 7 is 84 times the square root of 2x. So we're really looking at 45 minus 84, which would be, what, 39 times the square root of 2x. Negative. Whew. That would have been close. Okay. We're going to stop there and make the next video on rationalizing the denominator.